Hey everyone, probably the fifth or sixth time that I've recorded this, so hopefully this one works. Last time my mic wasn't working, and the time before that, it just, for whatever reason, just stopped recording. So, let's try again. 42 times 3 is the question that we have, and you've probably seen this kind of arrangement here in the study packet and or the Stepping Stones journal that the kids have been working on. And this is just helping the students transition from the area method of multiplication, where they use the shape like this rectangle with these two boxes in here to represent the place value of 42 times 3, and they would put their answers in here, and then they would add them up at the end. It's taking this picture representation and trying to move into the more abstract, and then eventually move into the standard algorithm. So with this method of multiplication and stepping stones, students break up 42 as 40 and 2, and they multiply it by the 3 because that's what's happening in the standard algorithm, and we will show that in later videos. But anyhow, this is 4 times 3 is the known fact, giving a student an answer of 12, but they know that this is 40 because they can see it here, and we've talked about it in class, and they just add that 0 in the end. This next step, this next product in the algorithm is 2 times 3, which is a known fact, and there are 2 partial products here. Students then will take a step further and add them together to get a final product of 126. Thus, 42 times 3 is 126. And I think that went off of the recording a little bit. I apologize. Oh, and it is kind of sloping up. But we get the point, right? Thank you for watching, and wait for more videos to come. Hey families, thanks for tuning in to another video. I'm going to take this time to show you guys the double half strategy that your children have brought home and hopefully not confused you with, or hopefully they're not confused with either. It in no way, shape, or form is meant to replace any of the other algorithms they already understand, but rather to enhance their understanding of multiplication and how we do it and why we do it. So the next couple videos will show doubling and halving strategies. And at any time, please pause the video if you need to. Email me questions if you have any, and I'll do whatever I can to help. Continuing with the discussion of doubling and halving, I'm going to take the example 15 times 16. Think real quick, get an answer, and you should have an answer, right? Just an easy one. 15 times 16, we know to be 240. To show children how it's possible to mentally multiply double-digit numbers, most people would ask the question, why do they need to do that? I'm sorry for the shaking of it. Oh, okay, we're good. Why would we need to do that? Well, it's to help children have confidence in multiplication. Check this out. If I double one number and half the other number, I've balanced the multiplication sentence, aka equation, and it's still going to be a working equation known as multiplication. If I double 15, taking half of 15 is not where we're at right now, but doubling 15, I get 30. Taking half of 16, I get 8. And now children can see a known fact in there. They can see 8 times 3, which is equal to 24. Adding that 0 from the 30 gives them 240. Think of an answer. When you got it, shout it out. Okay? I heard some good answers out there. Good job. You all are really starting to understand this. 45 times 12 we can look at as doubling one and halving another. Students get kind of aware, and I address it and make it aware if they don't see it, that you always want to double the odd number if there is an odd number. So 45 plus 45 is going to be equal to 90. Doubling one means you have to half the other, giving you 6. And you've taken 45 times 12, which is difficult to do in your head, and now you've made something where 9 times 6 we know is going to be 54. Adding the 0, and you're able to do that mentally. Does it always work that doubling and halving once makes it easier? Well, let's look at an example here. 28 times 25, and hopefully I'm not still, I am, look at that. It's like going, I'll try to get better. 28 times 25, where most of us would get our calculator out, and then most students would want to go to this algorithm here, or another algorithm that they use. This is completely fine. My purpose in doing this is to show students, hey, you double 25 up, you got 50. Okay? You have 28 and you got 14. Even that is easier than 28 times 25 because you've taken an 8 fact out of there and now you're dealing with 1, 4, 5, and 0. But what happens when you notice that one more double and half might in fact make it super easy? Some of you already see it. Think about it. I'll show you. Double that again, and you just made 100. Halving 14 makes 7. And friends, 7 times 100 is a lot easier than 28 times 25. Thus allowing children to feel empowered when they can do this mentally, that they can do 28 times 25 seemingly light speed compared to doing the double-digit multiplication algorithm. Is it better? Is it worse? I'm not saying that. What I'm saying is providing strategies to children to make them really feel that, hey, I'm awesome at math. I can do this. I can even do it in my head. Whereas before, I really struggled even putting it on paper. Does it work for everybody? No. Did I learn how to write horizontal compared to the board? Yes. Are these videos probably cheesy and corny? Probably. But the objective here is to get students to learn. It's to enhance their learning as much as possible and help them feel comfortable when doing math. As always, if you have any questions, please email me and contact me, reach out to me. More videos are to come, and I think we'll just stop here at partial products and double half strategies and see what happens. All right, thanks, guys. Okay, I said that I was going to be done with them, and I told a little lie. I apologize. I had forgot that I wanted to make a video about the SMART factors. And introducing factoring into multiplication in 5th grade is a really big concept. They did it in 4th grade, and I think some children may have caught on to it in 3rd grade, dealing with multiples and factors. For example, we know 2 and 8 are factors of 16. This 16 is a multiple with 8 and 2 as its factors. So in using that language, if I say factors, I'm talking about the single-digit numbers that multiply to make the multiple of 16. Sorry, hope that wasn't too fast. I'm not trying to run through this. I just want to get to the algorithm and focus on that. So if I'm looking at 35 times 8, it is completely okay to use an algorithm that works for you, this being 1, the standard algorithm of multiplication being 1. But in building on the understanding of doubling and halving, children can factor out 35 here. Leave 8 completely alone. He's a wonderful number. So is 35. I don't want to make him feel bad. But factor out 35 as 7 and 5. And now we've taken 35, found its factors of 7 and 5, and now we have a sentence of 7 times 5 times 8. Because we know, there it goes again, look at that, moving up, sorry. Because we know multiplication is commutative, that means it can move around and still be the same answer, I can look for a hero 0 in here. Or, can I multiply two numbers and get a 0 in the ones place? 5 times 8, these guys right here, they're going to give me 40. Bring down the 7. And now I'm doing 7 times 40, Or just looking at the known fact of 7 times 4. That's going to be 28. Add the 0, and I have 280. 35 times 8 is equal to 280. And we did it just by using some smart factoring. Is this strategy better than others? No. Do you have to use it? No. But being able to use it and feeling comfortable in using it and maybe trying it is my goal. I want the children to feel that they're capable to use it. I'm pretty sure this is going to be my last video for this little tutorial of multiplication as it pertains to Stepping Stones help. Thank you guys for watching, and as always, math is cool.